Well, this is Old Electronics Fan, and I'm back on my old Victor radio, RCA Victor, however it's identified, R35. And I'm back on this because even though the radio seems to be working perfectly fine, it seems to be behaving pretty well now that I've got new controls, the volume and tone controls in it. But I remember when I was checking the voltages that I wasn't very happy with them. So here's what I want to do. Here's what I've decided to do. I've made up this chart. There's a terminal strip over here. This chart shows me what the voltage is from pin 1 and 2, which are the filament voltages, 3 and 7, 3 and 6, 3 and 8. 3 is actually just ground. So they've got plate for the U24, for the 24 tube. I put in the identification from the documentation of UY-224, but they're really just 24, 27, and 45, because they no longer call them by their full name, and have it for a long time, I think. So this chart, and this also down here, amplifier sockets. Oh yes, okay. So this chart tells me what voltages should be going through the umbilical cord over into the radio part. So that's where I wanted to start, because I remember these voltages here, I wasn't crazy about them. So I also decided to look at the tube chart and see what it said the voltages should be. And these are the max voltages that should be on the tube. So that was the other thing I wanted to make sure of. So I have said this over and over again. People probably are tired of hearing me say it, but you can't fully rely on the schematics and, unfortunately, the documentation that you find for your vintage radio. One of the things I ran into was the capacitor blocks in this radio. The schematic said one thing, the documentation said another. And oh, I just cleaned that. It's dirty again. Anyway, so thankfully I still had one capacitor block that I had not touched. So I used my capacitor meter, and the meter confirmed what the schematic was saying. So the lesson I learned from that was, before you touch anything, find out if you can determine through your measurements how it should actually be wired. Because if I hadn't checked I actually redid one of the capacitor blocks, and one or two. And then as I was looking at this part of the schematic. Oh, stop it! I noticed some oddities that led me to believe that the information I was getting from the documentation was not correct. So I started looking further down the line, and I said, sure enough. And when I measured one of the capacitor blocks, that's when I found out that, yes, indeed, that information was wrong in the documentation. It was right in the schematic. Now, okay, these are DC. Filament voltage is probably AC. So right now, so I'm going to start, and that's going to be really fun to just, I'm going to start with the filament voltage. Let's see, and this umbilical is sending the voltage to the radio part, and in this case it's for the filaments. So let's go here, and here, come on, 2.5. So my meter is reading 2.5. My meter reads 2.5. The tube chart says 2.5. Normal voltage says it should be 2.4. Now this other meter over here is just there to let me keep an eye on the voltage, the AC voltage being fed to this. I've got this is hooked across the AC line coming in. The Sencor isolation transformer allows me to vary the voltage coming to this, and I decided to get that as close as I could when I was reading these. Now I'm going to mention something else that I mentioned in the previous voltage, but for someone who may not have seen that, when this radio was built, the voltage available in different areas of the country was not the same. Some places it was 110, other places around 120. This radio was set up so that you could set it for one or the other. And it's very important that you check on that. This one was actually set up for 110 when I found it, when I got it. Nobody had changed it. And this is very simple. There's a little doghouse that sits on the top of this. Take the screw out of it, take it off, move the fuse from one spot over to the other spot, and now you're changed. I don't know if it shows up. Yeah, it does kind of. It shows you that there's a fuse, and it shows you the 120 volts there, and then you got 110 here. So all you're doing is moving the fuse from this connection down to this one to make it correct. So you're putting it on a different winding of the coil of the transformer. So that's one thing. So I've got that. 3 and 7 is supposed to be 170. So let's check that out. 3 and 7. So 1, 2, 3. So this has, how many pins are you? 8. 1, 2, 3, 4, 5, 6, 7, 8. So this, on this chart, they go down to, well, let's just put this on ground, because that's where it needs to be anyway. So there's pin, well, let's go to pin 6. That should be right. Why aren't you, it's supposed to be auto, and it's pin 6. That's interesting. That's dancing around. It's saying 69, but, well, that's weird. 3. Well, that's weird. Well, this is a brand new meter, new to me. I've not run into that problem. Oh, that's AC, and it's supposed to be, that's why. It's gotta be DC. That's why it wasn't happy. Alright. The meter is apparently smarter than I am. I started out with AC because I knew I was going to be measuring filament voltage, which was AC. Alright, so 6. 108. Alright, put that in on 6. 108. Then we're going to go to pin 7. And that is 279. Oof. And then 8 is going to be, I got the pencil out of my hand, 103. 103. Oh boy. That's interesting. And it's got me a bit concerned. Well, this one is the one that worries me. Well, 275 max. So I guess it's okay. It's at the absolute max voltage. But here's the part that I don't understand. The filament voltage is almost dead on. But everything else is high. This says 65 volts. That's the plate for the audio tube over in the radio. but it's 108. There's some tolerance with regard to plate voltage, but, and I'm not sure how much range you are supposed to have. This says this tube can run at 250 max. I would like this to be within 10 volts of this, but so why? And this is 89 volts, this is 103, so that's like 14 volts higher. And this is 43 volts higher. So, and this is 100 volts higher. Why? This is where I start asking myself questions like, is the documentation for this radio correct? Okay, well, now I want to what do I want to do? Oh yes, I should turn this on. As you may have guessed, there was a gap between the part just preceding and now. That often happens. I have to go do something else, and then I come back. So, here we are. And so now what I want to do is, so we've looked at, oh, we don't want you going. So we've got the voltages for the radio part jotted in. Now I want to look at the voltages from the amplifier part. And let's see, I want to go here. And how are we doing? Alright, well I know it's playing, so it should be pretty close. My goal is to get this around 120. Now I know it's going to change a little bit as it warms up more, so that's close enough. So on the bottom part we've got a pair of 45s, and then we've got the 50 over here. So I'll have to move that out of the way at some point so I can get to that. But okay, so I've got one leg of this meter connected to the chassis of this radio, and let's see. Well, anyway, I've got that on DC, so we'll do that first. Alright, so the first thing that I want, I guess we want to go back to the AC, and we're going to go to filament voltage. So that was the first thing on my list, so I should do that first. So the 45 tubes, 2.45, I'll call it 2.4 for the 45s, 2.4, I'll put 4.5, that's what it was. And then we'll go over here to the rectifier, and that one is 5.1. Oh, okay. I wrote too large. 2.45, and that one is 5.1. Okay. All right. So, so on the next one, plate voltage. We're not going to be reading the plate voltage off the 280. We are going to be getting the plate voltage from the 45 tubes. Since that's the next thing listed on my 290. Plate is 290. Is this one the same? Close to? Yep. Alright, so that means both those tubes are pretty healthy. They're the same. Now, when it comes to the grid voltage, I don't get this. Oh, Yeah, alright, so, okay. What I'm doing is, I'm connected to the chassis, and I'm going down here to, these two bottom pins are the filament, they're also the cathode. So if I measure across from the chassis to the one of the filament pins on the tube, which is also cathode, I get a positive 45.8 volts. The well, that's interesting. I got something loose. I've chased that noise down several times before, and it seems to have come back. Well, anyway, maybe I got a noisy tube. All right, we'll worry about that later. Whoops. So the grid voltage should be a negative voltage, and so to get a correct reading of my grid voltage, I have to measure from the cathode, which is there, to the grid. And that's now a negative. You can see that little negative sign that shows up there. That's now a negative 45 volts. And that's what the grid voltage is. 45 minus 45. Now, I'll zoom in a little bit. So here's the voltages I've written down. This is a 2.45. Except I wrote it up in the wrong spot. I want it down here. 2.45 and 5.1. That doesn't belong up there. Oh well. Alright. So if you look at the documentation for this radio, you see that it says that it should be 2.5 volts. It's 2.45. This one is 4.9. Supposedly this is 5.1. So we got 0.2 of a volt off there and basically 0.2 of a volt off there, which is rather interesting. This should be a negative 37. It should be. It's reading a negative 45, which is a little bit high. But the plate voltage is 290. Now, the maximum voltage should be 275 on this tube, according to the tube manual. And if you're doing the maximum tube voltage, or maximum plate voltage, oh, will you stop? It should be a negative 56 volts for the bias voltage for the grid. So the next question is, how do I deal with that? And where is it? I don't know what I did with it. I was wondering if there was any, here it is, hiding at the very bottom. I was wondering if there was any information about what the AC, let's zoom in a little bit closer because this is small. This is the power transformer right here. It shows the filament 1, 2, 3, and this is the main with the center tap. And this is how easily you can get misdirected into thinking about things just plain wrong. I'm looking over here and it tells me that this is supposed to be 780 volts, and it gives me the color codes for the 3 wires that are coming from this main part of the transformer, because all your B plus volts is derived from this. So I'm looking at the black, blue, and yellow, red, and black, blue. TR. Anyway, so I'm thinking, well, how on earth am I going to find those? Because the colors have changed. And I'm just taking a quick look at there, and I might be able to see which one is which, but what about the middle one, yellow, red? Yeah. The thing is, will you please hush? The thing is, this was kind of misdirecting me because I don't have to find the wires coming from the transformer. All I need to do, and I'm thankful that I glanced at my schematic and spotted this. Guess what? Transformer, main transformer. And what was that, black, blue, and black, blue? Guess what they do? They go both to the plates of the rectifier tube. I don't have to find out which wires are coming from the transformer. All I have to do is go to where they connect. I tell you, it's so much easier to go find where the wires are connecting to than try to trace them from the transformer, especially since you aren't sure what the colors are. And of course, if I was thinking clearly, the obvious first thing to do would be to go straight to the point where they connect. And if you really want to trace them back to see where they go and what they go into, sure, that makes sense. But anyway, so what we're going to do is we're going to read the AC volts across here. And that's going to tell me what the voltage is that this thing is putting out. And so there we are, we're on AC. We'll put this, I'm going to back out here a lot. And so now, whoops, so here we are. I guess I'm going to put this back in the view here. So those top two pins are where our plates are on this. .803 volts. Whoa. Wow. Yikes. Well, I'm glad I'm using this meter because this one maxes out at 750 AC. What's the other one? Yeah. Whoa. Alright, this one's good up to 1,000 volts AC and DC. So I'm glad I bought this. I bought this recently, and part of me was thinking, do you really need 1,000 volts on both? And the other part of me said, maybe. As it turns out, I needed it. So we're going to say, I'm going to put this 800 volts here, 803. Yikes. Oh, write neatly, please. And 803 volts AC. Alright. The voltage listed here, I just mentioned, was supposed to be 780. It's a lot of volts. So, the question then is, this should be 780. It's 803. So it's 23 volts higher than they say it should be. This 222 is, I believe, 68. Yeah, 68 volts higher This is 68 volts higher than what they call out here. 23, 68. And then you go up here, and this is almost 100 volts higher. Okay, I'm thinking. All right, so, I mean, 23 volts higher, I can live with that. I mean, I have this set on exactly 120 volts, very close to. And you notice it's crept up a volt since I set it at 19. I knew it would when it warmed up. So, this voltage being only 23 volts higher than it's supposed to be doesn't account for this or this. So, as I thought about, I've been thinking about this, and there are two things that I remember from radios I've worked on in the past. One is when measuring, the instructions I've seen on some of the schematics is to measure the voltages for the grid and for the plate from the cathode. So, this is the 45 tube. I just measured plate voltage of 290 on the 45 tube. What happens if I actually do that? If I measure from the cathode, doesn't matter what side, I don't think, to, I think this is the plate over here. Aha. Alright. And we can go over here and here. It probably doesn't matter which one I use, which filament I use. Nope. 243, and this one was 243, 242. Alright. That makes me happier. So the 45 tubes, the maximum is supposed to be 275. The normal, according to the tube manual, is 250. I'm reading 243, which puts it very close to this. Not all that much more. Oh shoot, stop that. Not all that much more than this. So what are we talking about? 21 volts. This is 23 volts higher than it should be. So that difference between the 222 and the 243 could be explained by the fact that this is higher than it should be. Now that doesn't entirely explain this, 37 and 45, but it's definitely a whole lot closer than it. So this 290 is not accurate, and actually it makes sense because so 243 and 45 is 288. So basically what's happening is this number is the product of the voltage that's supposed to be on the plate and the bias voltage. There's a couple of volts difference. I'm not going to worry about that. But I think that's why this 290 volts exists, because I was measuring from the chassis, and as I showed you before, if you measure from the chassis to the cathode of the 45 tube, you've got, I think, what did I say, it was 45? Let's find out again. Yeah, 44, we'll call it, rounding off. So, yeah. So basically, your bias voltage was being added to the plate voltage, and that's why this number is so much higher than it should be. And this is 2/10 off, and this is 2/10 off. I'm just going to say that that's okay. This one is lower than the book calls for. This one is 1/10 of a volt higher. I mean, my meter could be, I know it's necessarily accurate, but it could be with, maybe this is reading 0.5 higher than it should be, so maybe this is actually 5.5, I don't know. I haven't compared this with anything else, so I don't know how it compares. So anyway, so this voltage now I'm happy with. So what about this voltage up here? Well, that brings me back to another radio. And its instructions, and it instructed you to measure voltage with the volume turned up. So let's see. Why are you down there? I drifted down a little bit. I'm not going to worry about it. Alright, so I want to know what's on pin 7. Alright, so we're going to pin 7. That says 275. Let's see what happens when we bring some... Oh, come on. Thank you. There it is. Okay. I can get it down to 245 volts by cranking the volume up. So this voltage well, anyway, last time I measured this was 279. So while that 245 that I just measured, or whatever it was, 245 I think, isn't this voltage, it's not above the maximum for this tube. Because this tube actually, well, yeah. So this tube maxes out at 275. This is the one, the 27, that maxes out at 250. The 24 tube maxes out at 275. Again, 250 is the, I wish you wouldn't keep doing that. I don't know if there's a way to change that timeout on me, on that. So this is what it considers to be the normal voltage. This is the max. But when I turn the volume up, this voltage drops down below this. It's not this, but it's not too high here. And obviously most of the time you're playing the radio, you're going to be playing it with sound. So I believe this plate voltage is fine. And I think I get the same things from, let's see, pin 6. Oh, wait, 106, let's see.
So you can win some cool movie tickets, cash.
96 volts. Alright, and then the other one is 8. Let's go down there. 101.
96.5 FM. Betting.
Okay, 93 volts. Alright, so that puts that within 4 volts of this. This one's a little bit further out because it was 94, so it's 31 volts difference here. So yeah, so the tube chart says that screen grid should be 90 volts. The book says it should be 89. This is saying it's 93. That's within 4 volts there. That's fine. The plate voltage, I'm not as worried about that. So, so two things that I've learned, that we've learned, I hope, when measuring the tubes down here, these 45s, you need to measure between the cathode and the grid and the plate to get accurate voltage readings. An easy way to find out what the output of your primary transformer is just read across the rectifier plates, and that will give you 800 volts. I wonder. Oh, that tube's going to be hot. Darn. I was going to pull the rectifier tube out and measure it, but I guess it doesn't matter. It's not going to be that much. It may drop by, maybe with the tube out, it may drop by 10 volts. I don't know. Keep from beeping at me. There. So, what are my conclusions? The documentation in this is, I don't think it's accurate. there's no way, given that the primary transformer, part of the transformer, the part that provides the B plus, it's only 23 volts higher than it's supposed to be. There's no way that this then becomes close to 100 volts higher. I mean, at idle, it's over 100 volts, but when you're actually playing it, it's what, 80 volts higher? But either way, I don't believe that. I just don't believe that number. It doesn't make sense. Like I said, the tube book, which I know manufacturers building radios don't always use these numbers. Sometimes they use lower voltages, but the tube manual says 250 volts is a normal voltage for this tube. I believe that quicker than I believe that. And when I'm playing it, I get 243, 245, somewhere in there. So I'm thinking that's the right number. And let's go back to, so now we still have a chart down here for the radio. I'm not going to go there and go through all that. Let me just show you why. Okay. These are the tubes. 4 tubes. These are the coils. There's 4 coils, one for each tube. That's also a coil, but that one you can't get from the top. But these are the coils that I care about. In order to get to the coils, because if you look at the schematic, which is over here. So if you look at the schematic, these are the coils that live under these, and there's one here too. If you wanted to measure the plate directly on this tube, you either have to unscrew the cover for that coil so you can get to the wires and figure out which one is which, or you take this shield completely off, top and bottom, and at the bottom of the tube there's little metal dots next to each of the pins. Then you have to figure out which pin is what, and then you go to that pin and you measure the voltages so you can get your plate and your grid and your cathode voltages by hitting these little contact points, test points at on the outside of where the tube goes. And you definitely want to use those, because if you try to go in from the side to go under the tube socket to get to the pins, you have a very high probability of shorting out the tube pin that you're trying to measure. Not ideal. So, anyway, so let's go back to this and why I'm not going to go there. All right. All right, so these voltages are all the voltages going up to the radio. And 24 tubes, plate, okay. The way they have it is 1, 2, 3, 4 are the 24s, 5 is the 27 tube. So plate, 3 of them are supposed to be 173 volts. If we go up here to 24 plate, the 24 plate, it says 170. What are the chances that I'm going to believe this number if I don't believe that one? That's number one. Number two, it's showing this voltage is higher than that one. I'm not sure why that would be. But given that this voltage is dropping into an acceptable range for that tube here, I think when I go to test it on the tube, on the radio, I'm going to find the same thing, that the voltage is going to be fine. So plate voltage, yeah. So, depending on which plate you're looking at, B plus, so it goes there, yeah. Well, alright. Plate volt B plus goes up here, plate voltage goes up here, goes through this little bitty coil, goes up here and goes into that plate. Chances are that voltage there is going to be very similar to the voltage I get down here on my B plus, my pin 7 pin 7. What I measure here is quite likely going to be the same thing I measure up here. 1, 2, 3, yes. So these 3 tubes, the same deal. Plate voltage, or B plus comes up, feeds the plate through this tiny little coil. I'm betting that those voltages are not going to be any different. And I say that because the radio works properly. I don't believe there's a problem with any of these coils. It tunes in stations, it's got plenty of volume for a local station. I don't think there's anything wrong with the coils. I don't think there's anything wrong with the voltages. The radio plays well. It's not what you call a long-range performer. It doesn't pick up signals from any distance away. It gets our local station and pretty much that's it. But apart from that failing, it's working fine. So I'm guessing that I don't have to worry about any of these voltages. And that was kind of the reason why I did this, was because, number one, I wanted to be sure that this radio was indeed working properly. And I was puzzled by these voltages, and they had me concerned, especially that 279 voltage. So, if this was the first radio I'd ever worked on, I would not have figured this out. It would not have happened. Because there were 2 things I needed to know. Number one is that some radios, you measure the voltage with the volume up. Also, you measure from the cathode to the plate on some radios if you want to get an accurate measurement of your plate voltage, and from cathode to grid to get your grid voltage. Some radios don't care. You can measure from chassis to grid and plate and get a reasonable voltage reading from them that way. I guess if you really want to be accurate, for instance, you've got a tube, your output tube maybe has -8 volts for the bias. Well, if you're measuring and it's got a resistor in the cathode bypass resistor, cathode and capacitor bypass in the cathode, you're going to be measuring, when you're measuring your plate so you're going to be measuring the bias voltage added to the plate voltage when you measure from chassis. Of course, you're going to be adding a -8 to 90 volts or whatever it is on the plate, so you could wind up with it saying 82 volts or something like that. On a lot of radios, I've actually measured plate voltage higher than the schematic says, or the documentation says, even though I'm measuring it from chassis. So probably if I measured it from cathode to plate, the voltage would be even higher. But I'm not, okay, I want to frame my thoughts here the way it makes sense. The voltages I worry about the most are grid voltage. Well, that's the screen grid. But, grid voltage and filament voltage, that one concerns me a great deal, because filament voltage that's higher by a significant amount than what it's supposed to be will shorten the life of your tubes. So you've got a 2.5 volt tube and you're running it at 2.8 or worse, 3. That filament isn't going to be happy for very long. It's going to die much sooner than it should. So I always want to know what my filament voltages are, especially if I've had to replace a selenium rectifier with a silicon diode. Because you're going to have to put in more resistance, a larger resistor when you do that, to replace the one that was there that was setting the voltage for the B+. Selenium rectifiers have their own internal resistance, which is higher than silicon diodes. So if you just swap in a silicon diode after pulling a selenium, all your voltage is going to be higher, including if this is a series string, which most of them are. Although not all, I guess some transformer radios have selenium rectifiers. Could, maybe. Bottom line is, if I've made changes that will affect the power supply to a radio I'm working on, I look for the filament voltage to make sure that is healthy. I also look for grid voltages. I want to make sure, especially the output tube, I want to make sure that is healthy. And of course, when I first fire up a radio, if I haven't done anything to it, I don't like leaving it on very long. And so one of the things that I try to do, and I try to remember to do, which I don't always remember, but I try to remember to do, is check the grid voltage to see if because I've seen radios where, it's supposed to be -8 or -9 or 10 or -5, whatever it is. I've measured them, and sometimes they're 8 volts or worse positive. That's a really bad thing for that tube. Your plate is going to get really hot very quickly. So, plate voltage, yeah, I'd like to have it somewhere near where it's supposed to be. I don't believe plate voltage is as much of an issue, though, as filament voltage and grid voltage. If all of my voltages are significantly higher, then I have to go and find out why. But that's one of the things that confused me about this, was that the filament voltages were reasonable. I mean, like I said, 2.4, 2.5. Book says 2.5. Here they're saying it should be 2.25. I'm coming out 2.45. 4.9, which is an odd number, but 5.1 is what I have. And, I'm thinking I'm happy with that. I'm wondering, well, yeah. I could measure this with another meter, but I'm pretty sure it's going to be close to the same. So, there might be a little variation from one meter to the next, so I'm not going to worry about that 1/10 of a volt. So I'm going to call this done. I'm no longer worried about these voltages, because I now know why my measured voltages were not correct. This one is okay, this one is okay. And that's what I cared about. So, documented voltage of 170, I don't buy it. I really don't. I don't think that's accurate. It says it here, it says it down here, 173. I don't buy it. I just don't think that's accurate. Because how do you have something that is that much higher when the only variation in your power supply is 23 volts? It's 23 volts higher. I don't believe it. So I'm happy with these numbers. I'm going to call that good. Now, I know that some people have done this, especially with radios they're particularly fond of, want to keep around long time. Some people may install a buck transformer and drop the voltage down. In fact, I already know from playing around, I already know that if I were to drop the AC voltage to this by 5 volts, the filament voltages come in very close to what they spec in their documentation. So if I wanted my filament voltages to be a little bit closer to what the book says, and it would drop all the voltages if you do that a little bit. Some of them actually drop quite a bit. Which one? I can't remember now. But I saw one go from, what was it? From 2, I don't know if it was this one. This one. One of them dropped down to 166 volts. And I can't remember. No, that doesn't make sense. No, 266. That's what it was. So it was either this one or this one. I think this one may have dropped down to 266 when I dropped the AC voltage by 5 volts. But since this number is bogus, you're typically going to be playing the radio. And when I measure it with the radio playing, it's 250. Now, since that dropped 266, that would be 24 volts difference. And it was around 40. If I had checked this with the radio playing, I bet the plate voltage would be very close to that with this thing at 115 volts. So, but the bottom line to me is, number one, are the tubes being harmed? I don't believe so. Number two, is the radio playing properly? Does it have proper volume? Is it distorted? Is there anything about the way it plays leading me to believe that there's something wrong with it? And with this radio, no, I don't believe there is. So, I am going to wrap this up here. I think I may have wandered beyond where I was going to stop, but that's okay, I guess. I'm really glad I did this. I know that there's at least one person who has one of these who's working on it. I hope this will be helpful to him. This has definitely been interesting. I've learned a bunch of stuff along the way. Learned some things, was reminded of some things, so that when I encounter stuff like this in the future, it'll be less of a surprise, and I won't be pounding my head against the wall trying to figure out, why is this not right? And I hope I remember this simple thing of, if you want to know what the AC source for your B plus coming off your main transformer is, go straight to your rectifier tube and measure the two plate leads, plate connections on your tube, and you will know. And you may want to pull the tube out. I think I'll do that. I think the tube is pulled off now. Alright. Yeah, it's cooled down now. So, this means my radio won't turn on, which is fine. We have volts. We do. Alright. So, let's go here, and we're on AC, and we'll go up here to our tube socket and find out what we have got. It was 803 before. Oh, ooh, okay. Alright, it's higher, which is not surprising. When that tube starts conducting, then the voltage does drop. So, excuse me, that right there is a warning to anyone who would be measuring the volts on the primary or the secondary that feeds the rectifier on a radio like this with a meter that only goes up to 750 volts. With the tube out, this thing puts out 845 volts. Just be warned. Okay, so I really am wrapping up here. Hope this was useful. If you liked it, punch the little like button down there, and if you're enjoying what I'm doing on this channel, then subscribe. I did enjoy it. I enjoy having you as part of the other subscribers who are following me on this channel. And hopefully you'll join me on the next video that I do, which right now I'm not sure what that is. But thanks for watching to this point, and hopefully to see you later.